Hi guys, what's up? So last time we went shopping for rotor stuff, and I showed you how I cut some slots in the rotor plates. And well, let's see what we're up to now. I made this new drawing in Fusion and then exported it so it can be opened in Inkscape. As you can see, the only thing that has been changed is the hole placement here, so that the rotor plates don't fall apart. And so I drilled those using the drill press, and as you can see, here is somewhat the result. I sort of forgot to take pictures in between, but okay, you get the idea. So there's 3mm holes here and there and there, and then there's this 5mm hole here. And also for the bearing holder or plate, there is these 3mm holes here. They're slightly offset so that, I don't know why, but I thought that would be nice. Next picture. Oh right, this picture actually is about how I, cut these slots further and then sanded them out so that thank you, I don't want Windows 11. Get out of here. Where were we? So I sanded these slots out so that the iron bars actually fit in. Next picture. And then you can see here is one of the rotor plates completely finished. Well, sort of. There's always these little things that, stop you from, moving further. Right, what I actually didn't show you in the last picture, here you can see that the holes here on one side are actually, sunk a little, so that the countersunk screws, or bolts, they fit in. So this is it for like the pictures. Let's see about the rest. So yeah, this is kind of what happened. Like I said, not a lot of pictures here or how it's built. It's more like it's right here, so we'll have to talk about it from here. You can see here these are also sunk, these holes here, so that the countersunk screws or bolts, they fit in properly. And yeah, what else happened? Like so many things. Like, okay, name one of them. Well, let's see. Like here, this starter plate here, this one right there. It was slightly, not circular, so I had to take it out and put the shaft into the drill so that it could be spun, and then I could file, it to be eventually sort of round, so it won't hit these iron bars here. Well, lots of little things like, you make these holes and they sort of fit, but they're so tight that you have to, have to put effort into it, so you re-drill it and such. So another thing is, these iron bars, they're sort of glued like a little bit, and so a tiny bit of pressure will actually break them. So as you can see right here, this one, I don't know if you can see that, you can sort of press it in, still has to be glued a lot more. So one of them broke, and I glued it up like way more. And remember, at the first time we glued it only at one side and then a little bit here and a bit in the center. So that made it a little bit like a cup. And so I took one of these, wait. This music is disturbing. So I put one of these upright on the table with a piece of paper underneath, and started dripping this glue inside, from the top into these holes. And every time you just leave a little drop and it would sink in, and then leave another drop and it would sink in. And this really makes it real strong. It's just that I don't have so many glue tubes right now, so I'll have to continue this later on. And my goal was to actually make this run today because, you can see I'm already so far. And it's far from ready, but it looks like it's going to be able to do some spin-up tests. So like as you can see, Well, yeah, you can't really see this, it's real heavy, and it's possible to rotate it already. And you can also see it snap a little bit into those magnets, like it really prefers to be there. So that's nice. I sort of thought that I would find a way to like make it run like this, but since it's so heavy and you know, I would make a 10mm hole onto something on the bench, clamp it on the bench, and then leave it like this and run it. But I'm thinking maybe it's better to have something hold it up like this on both sides. I'll figure it out. So yeah, what's the hold up then? Okay, well, I was hoping to get this ring around it so that when it does run a little bit faster, these iron bars won't fly out. But during the making process, I figured out that these iron bars are sort of tight. You can't really take them out. But in case they do sort of slip or move, I thought maybe just wrap a little bit of tape around it, maybe 2 or 3 times, that'll just do. And yeah, the next thing is finding a ring, you know, in the center there near the bearing that is going to be tight so that it doesn't have the ability to move up and down like this. And I also figured that maybe a little bit tape underneath the bearing and in between the bearing and the shaft, because it slightly moves, so a little bit of tape should do just fine there. And obviously to hold the, you know, the whole thing up so that it can move freely. So there's still some stuff to do, and yeah, well, the circuit, or basically the cables, you know, these yellow and red cables still have to be soldered to the power wire, and the trigger coil needs to come out from inside the tube here. There's still some work to do, and it may or may not run. This remains the question. I worked so hard, I just need a break and a cup of coffee. Even though this wasn't the final run test, it's still nice to see how much progress was made. And maybe there will be a run test, you'll see it soon. But for now, at least, thanks for watching already, and hopefully you'll see the run test now. Alright, so here she is. I mean, the motor. I sort of decided to go with the easy way, to just be able to spin it up here. And I tried it with a battery. I'll show you. So we get this inrush current to the capacitor. And then when we try spin it up, yeah, nothing happened. So I guess there's some work on this circuit. Maybe the trigger coil is the wrong way around, or maybe it won't trigger at all. I'm not sure. But I guess it's late, and we'll see another day. So anyhow, thanks for watching. See you next time.